Hello STAAD learners, welcome to the first video of this series titled Structural Mechanics with STAAD.Pro Connect Edition. We will begin off this series by explaining the very fundamental concepts of global axis system and the degrees of freedom. These concepts not only form the very basis of computer modeling and analysis of structures, but it's very fundamental to understanding the structural analysis itself. So let us see what these concepts are. Now let this ball B be in a space. Now let us imagine that this ball B is without any weight and it's not acted upon by any external forces. So under such condition, this ball B would remain dangling in space. Now let us say that we want to identify the relative position of this ball B from this point O. To do this, we have to define an axis system through this point O. The point O is called the origin through which the axis system originates. So let us define the x-axis as going horizontally from point O in this direction. So this is the positive direction of the x-axis and the negative direction of the x-axis would just be the opposite. The vertical direction would define the positive direction of the axis y. There would be one more axis to define the space, and that would be axis z, and that would be coming right out of the screen towards you. To make it legible on a 2D space, let us draw the z-axis like this. Now as I have said, this x, y and z-axis completely defines the space. The angle between the x and y axis would be 90 degrees. Similarly, the angle between the x and the z axis is also 90 degrees. And the angle between the y and the z axis would also be 90 degrees. So these three lines defining the axis are mutually perpendicular to each other. Now x, y and z cannot be drawn arbitrarily. It has some specific rules. You may know of these rules if you have taken a course in coordinate geometry in your schools. However, we'll still re-explain these concepts as understanding these concepts would be fundamental to a lot of later concepts that we will discuss in this series. Now we can think of this figure to help our understanding as to how the axis system is defined. Now we see that these are actually the various vectors. Now we can define the positive direction of the z vector as the cross product of the x vector and the y vector. Similarly, the cross product of the y vector and z vector would give the x vector, and so on. So this would mean that if we do a cross product of x vector and y vector, x to y will give z, so it will give the z vector. Y to z, so the cross product of y vector and z vector would give the x vector, and z to x would give the y vector. Would give the y vector. Now, what does this mean? How do we get the axis system, the direction of the axis system? So x cross y, let us use something called the right hand thumb rule. So basically we'll use this finger. When we say x cross y, let us take our fingers, let us curl our fingers from x to y. So you would see that this thumb would be pointing in this direction, which would be the positive direction of the z vector or the positive direction of the z axis. Similarly, y to z would give the positive direction of the x axis. So y to z is in this way. So if we actually curl our fingers in the direction from y to z, you will see that this thumb would be pointing in the direction of the positive direction of the x vector. Similarly, z to x, if we curl our finger in this direction, you will see that our thumb gives the positive direction of the y-axis. So the right hand thumb rule is used to determine the positive direction of the unknown axis when we know the positive direction of the other two axes. Now we can identify the location of the ball from the point O by measuring along the axis X, Y, and Z. We will discuss more about this concept when we discuss joint coordinates. I hope this explains the global axis system and the concepts are clear to you now. If you have liked this video, please do hit the like button and subscribe to my channel. To get more notifications from Structural Insider, please press the bell icon. See you in the next video. Thank you.